Hello, young math padawans. It's Mrs. Angel with your lesson for today on solving equations, variables on both sides. To start off, we're going to look at these two equations here. The first equation is 4x plus 8 equals 20, and the second equation, 4x plus 8 equals 20x. Before we can get into today's video, I need to go over some very important vocabulary words that I'm going to be using and that I want to make sure that you understand. The first word that I'm going to be using is term. If we recall, a term is separated by addition and subtraction outside of parentheses. So if I were to use that word with both of these equations, I would say that this first equation has two terms on the left-hand side of the equation and one term on the right-hand side of the equation. So I would say that there's two terms on the left and one term on the right. I could say the same thing for the second equation. The second equation has two terms on the left side and one term on the right side. So when we talk about terms in equations, we're talking about the number of terms on each side of the equal sign. The next vocabulary word I want to make sure that we understand are the different types of terms. So the first one is called a variable term, and that's essentially going to be a term that is a product that has a variable with it. So if you notice, the terms 4x and in the second equation 20x all have variables attached to them, which is why we would call these variable terms. The other terms in these equations don't have variables attached to them, 8 and 20. These are called our constant terms. A constant term is a term that just stands on its own. It's an integer, it's a fraction, it's some type of value, but it doesn't have a variable attached. Now, the final thing that we want to talk about are what are called like terms. Like terms are terms that are the same type, that have the same variable or no variable at all. If I had to combine some of these terms, I could only combine a constant with another constant or a variable term with other variable terms. In other words, you can't combine a constant and a variable term. Those cannot be combined. They are not like terms. So now that we've had a chance to go over some of this vocabulary, let's grab our notes and get started. Now that we've actually done some comparing and contrasting with these two equations, let's go in and solve them. So I'm going to start with the equation number 1. First thing I always do is put a line down the middle of my equal sign to keep the two sides of my equation separate. And something that I notice about equation number 1 is that the left side of the equation has two terms, 4x and 8. The right side of the equation only has one term. I'm going to go ahead and make a 0 term. And to do that, I'm going to subtract 8 from both sides using my subtraction property of equality. That creates a nice 0 term for me, and then after I simplify, I'm left with 4x equals 12. From here, now that I have one term on the left and one term on the right, I can go in and divide. Create a big one factor by dividing both sides by 4. I'm going to do a quick mental check. 4 times 3 is 12. 12 plus 8 is 20, so I know that x equals 3 is the solution to this equation. Let's take a look at this other equation. I'm going to start the same way. Put a line down the middle of the equal sign. Okay, I notice a lot of similarities here like we talked about. Two terms on the left, one term on the right. It'd be really great, just like we did in equation 1, to get it down to a single term and a single term, so then I could use my depot. But here's the interesting part. The term on the right side is no longer a constant like it was in equation 1. Now it's a variable term, which makes me think maybe we're going to have to do something different. I don't know. Let's just start off the same way and see what happens. Let's say I decided to start off the same way and subtract 8 from both sides. Using my subtraction property of equality, this is still a 0 term, so I'm down to 4x on the left. But can I combine 20x minus 8? Those aren't like terms. So what I've now done is I now have 20x minus 8 on the right side of my equation. It's still equivalent to what I started with, but am I any closer to solving? No, because now all I've done is now I have one term on the left, but two terms on the right. So this step didn't work. It didn't get me any closer to my goal. That just means we have to try something else. Another option could be to divide. We could divide everything by 4, and again, remember using depot, you have to divide all terms. That would make a big one factor, and we would have x plus 2 equals 5x. Well, our numbers are smaller, but I still have two terms on the left and one term on the right. and I'm nowhere near closer to getting it down to a single term and a single term. So there's one thing that we haven't tried yet. What if we were able to make a zero term out of 4x? How would we do that? Well, how do you make 0 out of a positive 4x's? You would have to take away those positive 4x's. So I'm going to subtract 4x. Well, by subtraction property of equality, even though this makes a 0 term, I still have to subtract it from the other side. Now, here's the interesting part. Can I subtract 20x minus 4x? Yes, I can, because those are like terms. I can go in and simplify here, because the left side now only has my constant 8, and the right side, 20x minus 4x, is 16x. And now, very similar to how I was in my first equation, I'm down to a single term and a single term, which means I can go in and divide. Now, careful. In doing this, our variable has now switched to the other side. So a very common mistake would be to go in and divide by 8. But we're trying to create a big 1 out of 16, not out of 8. So I'm going to go in and divide by 16, because 16 divided by 16 is a big 1 factor, and 8 divided by 16 is 1/2. I'm going to do a quick mental check. Half of 4 is 2. 2 plus 8 is 10. So the left side of this equation has a value of 10. Half of 20 is also 10, meaning x equals 1/2 is the correct solution here. So let's take some notes on what we just did here. So if we think about what we were actually trying to do in both of these equations, the goal was very similar. We were trying to use our addition property or subtraction property to create a 0 term first and make an equation that has 1 term on each side. If you can get any equation down to a single term and a single term, most of the time it's going to be dpo and done, sometimes mpo and done, but it definitely makes the math a lot easier. So keeping this goal in mind, let's try a few more. You try number 1. Negative 4x plus 28 equals 10x. I'm going to start this equation as I start all the rest with a line down the middle of my equal sign. Now, what's going to change about what I do next is I'm not just going to jump in and start doing some properties of equality. I'm actually going to look at this equation and think about what I'm going to do ahead of time. So what do I notice about this equation? Well, I notice that it has 2 terms on the left side, 1 term on the right side. So my goal is to get it down to a single term and a single term, meaning one of these 2 on the left side has got to go. My goal is to make a 0 out of either the 4x or the 28. Well, which one should I make a 0 term out of? That depends on what's on the other side. 10x is a variable term, meaning it can only be combined with other variable terms. So that leads me to believe that the only way that I can actually continue solving is to make a 0 term out of the negative 4x, because then when I use my property of equality, it can actually be simplified with 10x on the other side. So let's go ahead and do that. How do I make a 0 term out of negative 4x? I would add 4x's to it, because a negative and a positive is how we end up with 0. That creates a 0 term, and because of addition property of equality, I add it to the other side. Now, can I simplify? Well, let's see. The left side of the equation is down to a single term. I'm just left with my constant of 28. Can I combine 10x and 4x? Yes, I can. 10x's plus 4x's is 14x's. So by choosing to make a 0 term out of the variable, I was able to simplify. Now that we're down to a single term and a single term, why don't you finish this equation? Let's see how you did. I chose to divide both sides by 14x to create a big 1 and ended up with 2 equals x. Come over there to the check, and it does work out, which means that this is deserving of the box because x equals 2 is a solution to this equation. Let's take a look at you try 2. Same thing as always. I'm going to put a line down the middle of my equal sign and then just take a look at this equation. What do I notice? Well, I notice that this time the left side of the equation has a single term, which means I'm going to be directing all of my attention to the right side of the equation because the right side has 2 terms, and I want to get that down to a single term and a single term. So which one becomes 0? Well, it all depends on what's on the left. The left side of the equation is a variable term, meaning it can only be combined with other variable terms. So would I make a 0 term out of the negative 8x or the positive 18? You guessed it, I'm going to make a 0 term out of the negative 8x. How do I do that? By adding. Add 8x's to negative 8x's, and that creates a 0 term. Add 8x to the other side using your addition property of equality, and now we can simplify. Did we just get it down to a single term and a single term? Yes, we did, which means you can continue from here. Let's see how you did. So I divided both sides by 6 to create a big one factor, ended up with x equals 3, checked it over here, and it worked out, which means it is deserving of the box because 3 is the correct solution here. Let's move over to page 4 and continue looking at more examples. So number 1 on page 4, I start by putting the line down the middle of my equal sign, and what do I notice? Well, it looks like the left side of the equation has 2 terms. The right side of the equation has 1 term. So one of these 2 terms on the left has got to go, so I can get it down to a single term and a single term. Would you make a 0 term out of the negative 5x or the negative 7? Well, it all depends on what's on the other side. 23 is a constant. What can be combined with a constant? Only other constants, which means I want to make a 0 term out of the negative 7 because then I can combine it with the 23 that's on the other side. So how do I make a 0 term out of a negative 7? I'm going to add 7 to both sides using my addition property of equality. Negative 7 plus 7 is a 0 term, and when I simplify, I'm left with negative 5x. My variable term stays on the left, and 23 plus 7 is 30. Did I just get it down to a single term and a single term? Yes, I did, which means you can continue to solve from here. Let's see how you did. So the next step would be to divide both sides by negative 5, create a big one factor, and you end up with x equals negative 6, which, since it checks out, means it is deserving of the box because x equals negative 6 is the correct solution. On to number 2. I start every equation the same way. Line down the middle of my equal sign, and let's see what we're given here. On the left-hand side, I have 2 terms, 7x and a minus 9. The right-hand side is a 4x. So one of those 2 terms on the left has got to go. What's on the other side of the equal sign? It's a variable term. What can be combined with variable terms? Only other variable terms. So are we going to make a 0 out of the 7x or out of the minus 9? The 7x it is, because that is the variable term on the left-hand side. So to make a 0 out of 7x, we're going to subtract 7x, because 7x minus 7x is 0. Because of subtraction property of equality, we're going to do it to the other side. And now let's see if we can simplify. Now that we're down to a single term and a single term, why don't you finish this equation? All right, looks like next step would be to divide by negative 3, because x ended up on the right, and you get 3 equals x. It does check out, which means it is deserving of the box because 3 is the correct solution to this equation. On to number 3. Ooh, this one looks a little more challenging. I'm going to start by putting a line down the middle of my equal sign, and what do I notice? Well, the left side of the equation has a single term, and that single term happens to be a constant. But what does the right side have? It has 3 terms. So if our goal is to get down to a single term and a single term, then we've got to first go from 3 terms down to 2. Then we go from 2 down to 1. So how do we go from 3 terms down to 2 terms? For this, I thought it might be nice to bring back our solving equations tools. What if we were able to combine some like terms? Do we see like terms on the same side of the equation? I do. I see a 4x and a minus 2x, and since they're on the same side of the equal sign, we can combine those into a single term. So let's go ahead and do that. Let's combine our variable terms here. So because these are on the same side, I can just combine them as I see them. 4x's, take away 2x's, leaves you with 2x's. Bring down your constant and bring down the 22 on the other side. So now we've gone from 3 terms down to 2. Let's look at this one more time. The left side of the equation is a constant. The right side of the equation has a 2x and a 2. So which of these 2 terms on the right side will I make 0 out of? You guessed it, you're going to make a 0 out of the 2 because it's a constant and must be combined with the constant on the other side. Why don't you try finishing this one on your own? Let's see how you did. So after subtracting 2 from both sides to make your 0 term, you have 20 equals 2x. Divide both sides by 2 to make a big one factor, and 10 equals x. It does check out, which means it is deserving of the box because 10 is the correct solution. Let's quickly recap. So again, if it's our goal to get our equations down to a single term on both sides, it's all about which term you create 0 out of. In the first equation, we had to create 0 out of the constant because the other side of the equation had a constant term. In the second equation, we had to make a 0 out of the variable because the other side of the equation had a variable term. In both of these, we were able to successfully create an equation that had one term on both sides, which meant we're basically depot and done. That's it for today's lesson. I will see you next time.